start with our new topic, that is bone. In bone, we will discuss about mainly alveolar bone, parts of alveolar bone, composition, functions, remodeling, and age changes, right? Mainly you should focus on histology of bone because we are discussing about dental histology here. So we will be discussing about general anatomy of bone also, but very gross knowledge I will be giving about that. And we will discuss about the histology of the bone. So let's start with bone. What is bone? It's mainly a specialized form of connective tissue. It is an important element of skeletal tissues, composed of what? Cells and extracellular matrix, including fibers. Unlike any other connective tissue, bone is the only tissue that is calcified. It becomes calcified. So we will be discussing here about the alveolar bone, right? So what is alveolar bone? Alveolar bone. Alveolar bone is mainly a part of maxilla and mandible that accommodates the teeth with the help of PDL. It is mainly present based on teeth. If teeth are missing, it is poorly developed. It is vascular, mineralized connective tissue. Mineralized connective tissue. Right. Bone provides what? It provides mainly a skeletal framework and it acts as a reservoir of calcium ion. It provides what? Skeletal framework and it acts as a reservoir of calcium. It remodels mainly according to its functional demands. Bone marrow is present here. In between bone, we have bone marrow also. This bone marrow consists of what? Hematopoietic stem cells, which produces blood cells. Main function, it protects the underlying visceral organs also. Yellow bone marrow may be present. It depicts the storage of fat. It is mainly hard and rigid. Hard and rigid. Remodels according to functional demand. Mainly, all the bones are composed of what? Dense outer sheet made up of compact bone and central medullary cavity, right? So, basic appearance of bone we are discussing. So, it is made up of what? Dense outer sheet of compact bone. Dense outer sheet of compact bone and central medullary cavity. Medullary cavity is mainly filled with red or yellow bone marrow. As we have discussed, red bone marrow consists of what? Hematopoietic stem cells, which give rise to bone cells, blood cells mainly. And yellow bone marrow, it acts as a storage of fat. So, medullary cavity is filled with what? Red or yellow bone marrow. Red or yellow bone marrow. So, outer sheet is made up of compact bone and central medullary cavity. And spongy bone or trabecular bone is present at the extremities of the long bone. At the extremities of the long bone. Now, the tissue that covers the outer surface of the bone is known as periosteum. So, it has two layers, periosteum and endosteum. Periosteum, from the word itself, peri meaning surrounding. So, the tissue that covers the outer surface of the bone has two layers. Outer surface of bone covers outer surface of bone. It has two layers. Which are the two layers here? Outer fibrous layer and inner layer composed of cells, mainly osteoblast cells. So this periosteum has two layers, outer fibrous and inner osteoblast, inner cellular layer mainly. Inner layer having osteoblasts. Fibrous layer will be rich in blood vessels, nerves, composed of mainly collagen fibers, fibroblast, and inner layer is mainly cellular. Inner layer will be cellular, having osteoblast cells surrounded by osteoprogenitor cells. Endosteum. Endosteum meaning inner portion. Periosteum covers the outer surface while endosteum lines the inner bone cavities. Endosteum is composed of single layer of osteoblast. Single layer of osteoblast. And sometimes small amount of connective tissue is present. So basically a bone is having what? An outer compact sheet and inner medullary cavity, and it has two layers, periosteum and endosteum. Periosteum again has two layers, outer fibrous, inner cellular layer, while endosteum lines the internal bone cavities made up of single layer of osteoblast. What are the functions of bone? It acts as a supporting tissue, provides attachment to the muscles, reservoir of calcium ion. Important property of bone is what? Its plasticity. It is hard and rigid, but it has plasticity, remodeling. It remodels mainly according to the functional demand. Right. So basic, all the bones have what? Outer compact, inner medullary cavity, periosteum covering the outer surface, endosteum covering the inner bony cavities. And we will be discussing about alveolar bone also. So alveolar bone, from the word itself we can say it is a part of maxilla or mandible that supports the teeth through PDL. If teeth are missing, alveolar bone will be poorly developed. Its existence is mainly based on presence of teeth. Depends mainly on presence of teeth. It is mainly what? Part of maxilla and mandible that accommodate teeth through PDL. What are the functions? It is a mineralized supporting tissue, reservoir of ions, framework for bone marrow, attachment of muscles. Now we will discuss about the classification of bone, right? Normal classification of bone. Not alveolar bone, all the bones. Classification of bones. Basic classification of bone. According to shape. According to shape, long, short, flat, irregular, sesamoid, right? Long, short, flat, irregular, sesamoid. Long bones may be radius, ulna, tibia. Short bones may be. So according to shape, bones are classified as long, short, flat, irregular and sesamoid. According to development, they are again of two types. membranous, and cartilaginous. Membranous and cartilaginous. Cartilaginous from the word itself, it is preformed from cartilage. And membranous, we will be having what? It is derived directly from embryonic connective tissue, membranous type. Some bones are membranocartilaginous, such as our mandible. Membranocartilaginous. Membranous from the word itself, we can say that it develops directly from our embryonic connective tissue, ectomesenchyme. So it is membranous, cartilaginous from preformed cartilage, and sometimes we have bones that are combination of both membranous as well as cartilaginous. Membranocartilaginous. Mandible is an example of membranocartilaginous bone. Now, histologically, according to the density, right? We will be having according to histology. Compact bone and cancellous bone. Compact bone is, we have seen recently only that it is covered by a thin layer of outer sheet is made up of compact bone, right? So compact bone, as it covers the outer portion, it should be strong. So compact bone is strongest and dense. It forms outer covering, smooth, white, solid. Mainly, it constitute 80% of skeletal framework, right? Its bone matrix consists of what? Organic and inorganic components. Small space is present, that is lacunae. In this lacunae, osteocytes will be present. As we have discussed, it is covered with periosteum on outer surface and endosteum on inner lining. And endosteum on inner lining, inner surface, right? Now coming to important part is the compact bone is strong and dense. It has its structural and functional unit. Same as we have structural and functional unit of enamel, that was enamel rod. Here, structural and functional unit of compact bone will be osteon. Structural and functional unit will be osteon. It is mainly osteon. In the center of this, we have Haversian canals, which consist of blood vessels, nerves, lymphatic vessels. So, Haversian canals. What are Haversian canals? They are present at the center and they consist of blood vessels, nerves, lymphatic vessels, blood vessels, nerves, lymphatic vessels. A concentric layer, a cylindrical structure made up of concentric layers is present, which is lamella. Cylindrical structure made up of concentric layers known as lamella is present. So there are three types of lamellae based on their location. Three types of lamellae based on their location. Based on their location. Which are the three types of lamellae? Concentric lamella, circumferential lamella, and interstitial lamella. Circumferential lamella. concentric lamella surrounds the Haversian canal in circular motion. So it surrounds in circular pattern. Interstitial that present in between the concentric lamella. Present in between concentric lamella. And circumferential, they are parallel to entire circumference of the bone. Parallel to entire circumference of bone. Right? So they surround both concentric lamella as well as interstitial lamella. And encircle concentric and circumferential lamella. So in histology of this compact bone, mainly it is strong, it is dense, right? It is the outermost covering. It has outer periosteal layer, inner endosteum layer. Basic structural and functional unit is osteon. Structural and functional unit of bone is osteon. Right. In this diagram, we can easily appreciate periosteum as well as endosteum. Endosteum, it is the inner lining. Right. Osteon, can you see here? This is osteon. The center we have Haversian canal here. This Haversian canal is surrounded by lamellae. This lamellae are named according to the location, right? Outer circumferential lamellae is present where? Here. This is outer circumferential lamellae. Then we have interstitial lamellae here in between. So, we have seen diagram also. Haversian canal, concentric lamellae, circumferential lamellae and interstitial lamellae. So, interstitial are present between two concentric lamellae. In this diagram also you can appreciate. This is central Haversian canal surrounding concentric lamellae, right? These are the concentric lamellae and in between two concentric lamellae is our interstitial lamellae. And surrounding both we will be having circumferential lamellae. In this diagram also we can see. This is the osteon here. Central Haversian canal, right? And these are the concentric lamellae. Between two concentric lamellae, we will be having interstitial lamellae. And circumferential lamellae will be surrounding both interstitial lamellae as well as concentric lamellae. So, compact bone, presence of lamellae, osteon, Haversian canal, Walkman's canal. Walkman's canal connect to Haversian canals. It is mainly a perforating canal. Blood vessels, nerves branch off at 90° through this perforating canal and it joins two Haversian canals. So, we have discussed what? We have discussed compact bone. In compact bone, we have discussed what? What is it mainly? It is hard, it is compact, it consists of what? Osteon, Haversian canals, three types of lamellae. Also, we have discussed concentric lamellae surrounding the Haversian canals, interstitial lamellae between two concentric lamellae, and circumferential lamellae surrounding both concentric as well as interstitial lamellae. One thing is remaining here we have not discussed about is Walkman's canal. Walkman's canal. It is mainly a perforating canal through which blood vessels, nerves branch off perpendicular, right? And this canal connects both two Haversian canals. Now coming to cancellous bone, right? Cancellous bone is mainly spongy bone. It is spongy. Or trabecular bone. It is less dense. It constitutes only 20% of the skeletal framework. Consists of what? Red blood bone marrow. Volume is 10 times more as compared to compact bone. This red bone marrow is involved in what? Production of red blood cells. Mainly red bone marrow is involved in production of red blood cells. So this is, it is mainly spongy bone or trabecular bone. It has red bone marrow, contains red bone marrow, mainly involved in the production of the red blood cells. Volume is higher, 10 times higher as compared to compact bone. Now, another classification is according to microstructure. So we've seen till now shape, histology, right? Development. According to microstructure. Fine fiber bundle and coarse woven bone. Fine fiber bundle or coarse woven bone. Fine fiber is mainly mature. It is lamellated bone. Mature lamellated bone. Parallel to the collagen fibers. Mainly parallel arrangement of collagen fibers. Coarse woven, from the word itself we can say there is haphazard arrangement. Haphazard arrangement of collagen fibers. Rapid laydown of bone. New bone is formed over the pre-existing bone. New collagen fibers are formed by osteoblast over the pre-existing connective tissue. So here we have, according to microstructure, fine fiber bundle and coarse. Fine, mature, lamellated. Here parallel arrangement of collagen fibers is seen, while in coarse woven bone, what is seen? Haphazard arrangement of collagen fibers is seen. It occurs when there is rapid laydown of bone. Now coming to formation of bone. So classification we have discussed according to shape, according to development, according to histology, according to microstructure. Histology is important, so we have discussed slightly in detail about compact bone and cancellous bone. Again, in alveolar bone, we'll discuss about the histology of the alveolar bone, which will be same as this mostly. Now coming to formation of bone. Formation of bone, as we have seen, genesis. Genesis means formation. Bone formation is known as osteogenesis. Osteo meaning bone, genesis meaning formation. So osteogenesis is formation of bone. Osteogenesis. Ossification. Bone is formed by what? Bone forming cells. Which are the bone forming cells? Blast cells, mainly osteoblast cells. So laying down of bone by bone forming cells. It is osteogenesis. Laying down of bone by bone forming cells. Osteoblast. During early embryogenesis, embryoskeleton is made up of what? Hyaline cartilage and fibrous membrane. So initially, during early embryogenesis, embryoskeleton is made up of two things: fibrous membrane and hyaline cartilage. Fibrous membrane and hyaline cartilage. Hyaline cartilage. Now, with progressing weeks, that is during 6th to 7th week of intrauterine life, bone formation starts. Initially, embryoskeletal is made up of only fibrous membrane and hyaline cartilage. But by 6th to 7th week of intrauterine life, what will happen? Bone formation will start. This bone formation is formed through two pathways. Bone formation starts mainly through two pathways. Which are the two pathways here? Either intramembranous or endochondral bone. So bone formation is mainly what? It is osteogenesis or ossification. It is mainly laid down by bone forming cells, that is osteoblast cells. Early during embryogenesis, embryoskeleton is made up of fibrous membrane and hyaline cartilage. But with a 6th to 7th week, bone formation starts through two pathways. Either, not both the pathways, either one of them. It forms through intramembranous and endochondral. Intramembranous and endochondral. Intramembranous and endochondral. Both involve transformation of pre-existing mesenchymal tissue. But there is a difference. In one, that is direct conversion. In another, I will discuss. So, in intramembranous, there is direct conversion of mesenchymal tissue into bone. Direct conversion of mesenchymal tissue into bone. Direct conversion. While in endochondral, what will happen? Mesenchymal cells will differentiate into cartilage, and this preformed cartilage will be then replaced by bone. So here there is direct conversion in intramembranous type. There is direct conversion of mesenchymal tissue into bone. While in endochondral ossification, what is happening? Mesenchymal cells differentiate into cartilage, and they are replaced by bone. So osteogenesis is not very difficult. Initially, it is the embryo skeleton is mainly made up of what? Fibrous membrane and hyaline cartilage. Later on, bone formation starts through two pathways: intramembranous and endochondral. Endochondral, there is no direct conversion. In endochondral, first mesenchymal cells will differentiate into cartilage and then bone will be formed. While in intramembranous, there is direct conversion of mesenchymal tissue into bone. So we've discussed about the development of bone. Now coming to the development of alveolar process. Alveolar process is, again we have discussed, it is dependent on presence of teeth, right? Development of alveolar process. So we have discussed this alveolar process is mainly dependent on presence of teeth. So during bell stage, bony septa and bony bridge start to form. Septa meaning it is divided the individual tooth gum and separate the individual tooth gum from one another, keeping the individual tooth gum in clearly outlined bony compartment. This type of compartments are seen, right? So this portion will be our alveolar bone. Bony septa and bridge develop, and here our tooth bud will be present. So it separates the tooth gum from one another, bony septa, keeping the individual tooth gum in clearly outlined bony compartment. This bone forms a thin eggshell of support, which is known as tooth crypt. Tooth crypt. As bone, this bone forms thin eggshell support. Thin eggshell support. It is known as tooth crypt. Tooth crypt around the tooth gums. So alveolar process is mainly tooth dependent. It is separating the developing tooth gums from one another. Thin eggshell support. It acts as a thin eggshell support. It is known as tooth crypt around each tooth germ. One more factor may be involved. You can be asked as an MCQ question sometimes, right? Which factor is involved? CBFA1. It is core binding factor alpha 1. It is involved in osteoblastic differentiation and osteogenesis. This factor helps in osteogenesis. CBFA1, core binding factor alpha 1. It plays an important role in osteogenesis and osteoblastic differentiation. So CBFA1, this can be asked as an MCQ question. And another one is BMP, bone morphogenic protein. It also plays an important role. It converts the mesenchymal cells into the osteoblast cells and lead to the formation of bone. So these two factors also play an important role in bone formation. Now coming to composition of bone. What is bone composed of? As we have seen in our enamel, dentin, same. Organic as well as inorganic components. And organic components. So inorganic, 67% inorganic composition, mainly hydroxyapatite, Inorganic, we have 33%, right? So in organic, what we will be having? Mainly collagen, type 1 collagen. This can again be asked as an MCQ question. Which type of collagen is common in bone? So type 1 collagen. What is the formula here? Ca10 PO4 6 OH2. And type 5 and 3 are also present in small quantity. Then we have non-collagenous proteins also, right? So this is basic organic and inorganic components. And we will be having collagen as well as non-collagenous proteins here. Inorganic, non-collagenous proteins. Which are the non-collagenous proteins? Bone yellow protein, osteocalcin, osteonectin, osteopontin, right? Bone yellow protein, proteoglycans, growth factors. This all proteoglycans, growth factors. These are the non-collagenous proteins. Ground substance may be present, glycosaminoglycans, proteoglycans, water. Osteopontin and bone yellow protein are cell adhesion proteins mainly. Calcium binding proteins. Osteocalcin is mainly calcium binding protein helping in mineralization. So these proteins mainly help in what? Mineralization. This non-collagenous proteins help in mineralization. Presence of collagen is very important. Why? Because it resists the load to prevent the fracture. Now coming to structural elements of bone, mainly cells. We have cells of bones also. Cells of bone. Structural elements of bones are cells. So which will be the cells of bone? 4 types of cells are present here. Mainly we will be having osteoblast, right? Osteocytes, bone lining cells, osteoclast, and there can be one more cell that are osteoprogenitor cells. Osteoprogenitor cells. So osteoblast, from the word itself, they're involved in bone formation. Osteocytes, as we had seen cementocytes, right? During the formation of cementum, some cementoblasts get entrapped within the matrix. They're cementocytes. Same way in bone also, when the osteoblast get trapped in the matrix, once bone matrix is formed, they should move away from the matrix. But sometimes the cell gets entrapped within the bony matrix, and these cells are known as osteocytes, that are osteoblast entrapped in the matrix. They secrete. Osteoblast entrapped in the matrix, which they secrete. Bone lining cells. They are just lining the bone. They are inactive osteoblasts that cover the available bone surface, and they act as a barrier against the ions. Bone lining cells, they are what? They are inactive osteoblast. Inactive osteoblast. They are available on the bone surface and they act as a barrier. Act as barrier. Osteoclast, again, these are involved in resorption of bone. They remove the bone tissue by removing its mineralized matrix. Resorption of bone. Osteoprogenitor cells. Progenitor cells, they are undifferentiated cells found near the surface of the bone, which under certain circumstances undergo division and transform into osteoblast or coalesce to give rise to osteoclast. So they can be converted into osteoblast also or osteoclast also. So they are mainly undifferentiated cells. They are mainly undifferentiated cells that under some circumstances may undergo transformation and form osteoblast or this osteoblast sometimes coalesce and form osteoclasts. So cells of bone: osteoblast, osteocyte, osteoclast and osteoprogenitor cells. Bone lining cells: inactive osteoblast, and they act as a barrier against the ions. These were the cells of bone. Sharpies fibers are also present, as we have discussed. They are a portion of PDL fibers entering the bone. Also, bone can have blood vessels, nerves, lymph vessels. Now coming to the newly deposited bone. Newly deposited bone is known as osteoid. It is unmineralized bone matrix newly deposited on the surface of the active bone. 5 to 10 mm in thickness. Type 1 collagen is mainly present here, embedded in ground substance of proteoglycans and glycoproteins. Mineralization will take place by osteoblast from whose cell membrane vesicles are burred off. So here it is unmineralized matrix. After that, mineralization will start. So cells of bone, only you should remember the functions here: osteoblast, osteocyte, what are osteoclast. If slide in detail for university exam, osteoblast, what is the shape of osteoblast? They're differentiated from what type of cells? They're high in alkaline phosphatase activity. So just we will have some description of the cells, discussion about the cells. So osteoblast for the university exams. Otherwise, from MCQ point of view, what was important we have discussed. Osteoblast are what? Bone forming cells. What is the shape of osteoblast? Plum. Cuboidal cells. Mononuclear cells. Plum. Cuboidal cells. Mononuclear. Synthesized collagenous as well as non-collagenous bone matrix protein. It contains high level of alkaline phosphatase. This is important from MCQ point of view. High level of alkaline phosphatase. Abundant protein synthetic organs such as RER are present here. It secretes cytokines, growth factors, osteoprotein, growth factors, right? So it is high level of alkaline phosphatase. This is important from MCQ point of view. Then it is differentiated from dental follicle cells. Differentiated follicle cells, pluripotent follicle cells, dental follicle, right? Increased cell organelles such as RER. It secretes what? Rankle OPG, osteoprotein, and growth factors. Cytokines. Osteocytes, we have recently discussed, they are present and trapped within the bone matrix. More rapid the bone formation, so osteoblast cells will have no time to move outside. So more osteocytes are present. As the osteoblasts get entrapped because of rapid bone formation, more osteocytes are present per unit. Osteocytes are present where? In bony lacunae. Canaliculi of osteocyte maintain contact with adjacent osteocyte and osteoblast or bone lining cells with their osteocytic process. This type of process may be present in osteocyte. So through this process, they maintain contact with the adjacent osteocyte and osteoblast. Canaliculi penetrating the bone matrix permit the diffusion of nutrients, gases, waste products between the osteocyte and the blood vessels. Through this canaliculi, what will happen? It permits the diffusion of nutrients, gases from what? The blood vessels. They can sense the change in environment and send signals to the other cells that are involved in remodeling of the bone. Failure of interconnecting between the osteoblast and the osteocytes leads to mainly death of bone or sclerosis. So in osteocyte, we have seen what? It has canaliculi, it has canaliculi through which it maintains the contact, and if failure is there, then it may even result in death of bone. Through this processes, it helps in diffusion of gases, waste products, nutrients between the blood vessels and the bone. Bone lining cells, they're inactive cells that just present on the outer surface, they act as a barrier, which we have discussed. They're flattened cells. They're present on bone when it is not in formative or resorptive phase. Progenitor cells also, they act as a stem cells. We have discussed progenitor cells. They can convert into osteoblast or osteoclast even. Osteoclast. They're mononuclear cells? No. They have multiple nuclei. They're derived from what? Monocytes. They're derived from monocytes. This osteoclast has what? Ruffled border. This type of cell may be there. So it has ruffled border, nuclei and sealing zone, clear sealing zone, functional secretory domain and basolateral surface. So osteoclast, just as osteoblast has some receptors, it has receptors for calcitonin, prostaglandin, rank and parathyroid hormone. It has receptors for calcitonin, prostaglandin, and rank and parathyroid. So what is involved in the formation of osteoclast? MCSF and receptor activator of nuclear factor KB ligand. RANKL, rankle, receptor activator of nuclear factor KB ligand, which are released by the osteoblast, are important for differentiation of myeloid cells to mononuclear osteoclast precursor. Osteoblasts secrete what? OPG, osteoprotogerin, which binds with rankle and inhibits osteoclast formation. For formation of osteoclast, rank and rankle signaling is important. This is important for osteoclast. But osteoblast secretes OPG that combines with rankle and inhibits osteoclast formation. This combination, rank and rankle is important for what? Fusion of mononuclear osteoclast to multinuclear osteoclast. And for inhibition, osteoblast secrete OPG, which binds with rankle and inhibits the osteoclast formation. So this leads to osteoclast, causing resorption of bone. And to stop that, osteoblast secrete OPG that will bind with rankle, leading to inhibition of osteoclast. Coming to bone remodeling, there are 4 stages: resorption, reversal, formation, and resting. Resorption, reversal, formation, and resting. From the word itself, resorption, we can see which cells will be involved? Osteoclast. So here in resorption, there will be recruitment, migration, activation of osteoclast causing bone resorption. So there will be activation of osteoclast, migration of osteoclast causing bone resorption. In reversal, there will be stopping of resorption, cessation of resorption, and disappearance of osteoclast by apoptosis, and the site becomes occupied by mononuclear cells. So in reversal phase, once resorption starts, reversal start. Cessation of resorption. Disappearance of osteoclast. For resorption, only osteoclasts are important, but here resorption is stopping. So osteoclast should not be there. So there will be disappearance of osteoclast by apoptosis, and the site will be occupied by mononuclear cells. Formation. For formation, which cells? Again, osteoblast cells. So osteoblast cells, there will be migration, recruitment, differentiation, and they will start new bone formation on the resorption site. New bone formation on resorption site. Resting. Formation of new bone ceases and the surface is lined by flattened layer of cells. Resting phase, no bone formation, no bone resorption. So here formation of new bone stops here and the surface will be lined by flattened layer of cells. This is mainly remodeling. Here we can see resorption starts by the presence of osteoclast cells. Then reversal. Reversal, what will happen? cessation of resorption and mononuclear cells will be present here. Then what will happen? Formation. So here we can say bone formation is there. And then resting phase. No bone formation again. Resting phase. It will be lined by flattened cells. For bone remodeling, resorption, reversal, formation, resting stage. Resorption, osteoclasts are important. For reversal, what is happening? Cessation of resorption and disappearance of osteoclast by apoptosis, and the site becomes occupied by mononuclear cells. Formation, osteoblast recruitment and formation of new bone on resorption site. Resorption site. Resting, formation of new bone stops and surface is lined by flattened layer of cells. Flattened layer of cells. So now coming to our main alveolar bone. Alveolar bone is also known as alveolar process. It is the specialized bone that contains alveoli or socket of the teeth and supports the teeth. So coming to alveolar bone. It is mainly alveolar process, also known as alveolar process. It is a bone that contains tooth sockets of teeth and supports the teeth. It is purely tooth dependent. If tooth are absent, it will disappear. It is composed mainly of two parts: alveolar bone proper and supporting bone. So alveolar process is what? That part of maxilla and mandible that forms and supports the tooth socket. That part of maxilla and mandible that form and support tooth socket disappears with the loss of tooth. This we have seen. Because alveolar process develop and undergo remodeling with tooth formation and eruption, they are mainly tooth dependent structures. They develop from what? We have seen in our first topic, tooth development. They arise from dental follicle. Dental follicle. Remember, this dental follicle converts into three types of cells: osteoblast, giving rise to bone, cementoblast, cementum, and fibroblast, PDL. So alveolar bone is mainly consists of two parts of alveolar bone. They are alveolar bone proper and supporting bone. It is derived from dental follicle. Ectomesenchymal cells of dental follicle differentiate into osteoblast and lay down matrix known as osteoid. This osteoid is unmineralized bone matrix. Dental follicle ectomesenchymal cells of dental follicle differentiate into odontoblast. Differentiate into which cells? Osteoblast. Osteo meaning bone, blast meaning formation, and they form osteoid, that is first unmineralized matrix of bone, which will later mineralize to form bone. Some osteoblasts become embedded in the matrix and they are known as osteocytes. So we had discussed about what is alveolar bone parts. Then coming to the formation, dental follicle cells differentiate into osteoblast cells which lay down osteoid, which is initial unmineralized matrix which later undergoes mineralization and forms bone. Now coming to alveolar bone proper. What is alveolar bone proper? Alveolar bone proper. It is a thin lamella of bone that forms the inner wall of the tooth socket. It is thin lamella of bone that forms inner wall of the socket. Inner wall of tooth socket. What is thickness? 0.1 to 0.4 mm, and it surrounds the root of the teeth. It surrounds the root of the teeth and gives attachment to PDL fibers. PDL fibers gives attachment to PDL fibers. So it surrounds the root, it forms the inner wall of the socket, it surrounds the root, gives attachment to the PDL fibers. It is also known as cribriform plate. Alveolar bone proper is also known as cribriform plate. It is also known as cribriform plate. Lamina cribrosa. Lamina cribrosa. Why it is known as cribriform plate? Because it is perforated. It is perforated by many openings that transmit the intraalveolar nerves and vessels. So why it is known as cribriform plate? Because it is mainly perforated. It is mainly perforated and has many openings for intraalveolar nerves and vessels. And has many openings for intraalveolar nerves and vessels. Though it has perforations, it appears radio opaque on radiograph, not radiolucent. Radio opaque is white, radiolucent is black. So in spite of having perforations, it appears radio opaque. Radio opaque on radiograph. So radiographically it is known as lamina. It is known as what? Lamina dura. Lamina dura. So you can be asked, what is lamina dura? It is a radiographical name for alveolar bone proper. Radiographically, it appears radio opaque. So alveolar bone proper is mainly a thin lamella of bone covering the inner wall of forming the inner wall of the socket. It covers the root and provides attachment to the PDL fibers. It is also known as cribriform plate. MCQ question. Alveolar bone proper is also known as cribriform plate. Lamina cribrosa. Lamina cribrosa. Why cribriform? Because of perforations. Because of perforations. In spite of perforations, it appears radio opaque. It appears radio opaque. And this radio opacity is known as lamina dura. So this can again be asked as an MCQ question. What is lamina dura? Or you can be asked as a university exam question, parts of alveolar bone. So parts of alveolar bone, we are discussing first part, that is alveolar bone proper. So we have seen its cribriform plate. It is also known as lamina dura radiographically. Now the bone partition between two teeth. Between two teeth. This is teeth here. The bone partition between two teeth is known as interdental septum. Between two teeth, interdental septum. So bone partition between two teeth is known as what? Between means inter. Teeth means dental. Interdental septum. Interdental septum. So many terminologies we are seeing in alveolar bone proper. Cribriform plate, lamina dura. Now coming to interdental septum. So bone partition between two teeth is known as interdental septum. It is made up of what? It is made up of entirely of cribriform plate. It is made up of entirely of cribriform plate. Now coming to interradicular septum. Interradicular septum. Is this interradicular? Again, it is made up of cribriform plate. Interradicular, from the word itself we can say it is present between the roots of multi-rooted teeth. So these are the roots here. It is present between the roots of multi-rooted teeth. So interradicular septum is mainly made up of cribriform plate and it is present between roots of multi-rooted teeth such as molars and premolars. So between two teeth, interdental septum, interdental between two teeth, and interradicular, from the word itself, radicular meaning root, right? So between roots of the same teeth. So interradicular septum. Cribriform plate because of the perforation, lamina dura, radio opaque on radiograph in spite of having perforations. Interdental, interalveolar arteries, veins, lymph vessels, and nerves lie in a canal called perforation canals of Hirschfeld and Zuckerkandl. So this is again an important MCQ question. Zuckerkandl and Hirschfeld. Zuckerkandl and Hirschfeld. Here what? Interdental, interradicular veins, vessels, nerves lie in a canal. They are known as Zuckerkandl and Hirschfeld canals, perforating canals. Interdental, interradicular, arteries, veins, lymph vessels, and nerves line perforating canals known as of Hirschfeld and Zuckerkandl. So we have completed with our alveolar bone proper, right? Alveolar bone proper, we have seen the gross anatomy, interdental septa, septa meaning it acts as a fence or a wall. Septa meaning between wall between two teeth. Interradicular septa between roots of multi-rooted teeth. Cribriform plate also we have seen. Perforations are present, so it is known as cribriform plate. It is also known as bundle bone. Sieve-like appearance. We have seen sieve perforations in a sieve. Sieve-like appearance is seen in what? Cribriform plate. Sieve-like appearance. Now coming to supporting alveolar bone consists of cortical plate and cancellous bone. Cortical plate and alveolar bone. So in the starting only we had seen about the cortical bone, right? Cortical plate and alveolar bone. Sorry, cancellous bone. Cortical plate, the structure of cortical plate is similar to compact bone. We had seen it is a strong, dense bone. So it is similar to compact bone. Structure is similar to compact bone. It is made up of lamellar bone. Right, we had seen na? Starting of the topic. lamellae, interstitial lamellae, concentric lamellae, circumferential lamellae. Haversian system was present, which consists of nerves in the center. Osteon was present, cylindrical, basic structural and functional unit of bone. So here the cortical plate in supporting alveolar bone, it consists of two parts, cortical plate and cancellous bone in the center and cortical plate surrounding the root portion. So here the cortical plate is having appearance similar to the compact bone. It is mainly lamellar, consisting of Haversian canal and interstitial lamellae. Canal and interstitial lamellae. What was interstitial lamellae? Between two concentric lamellae. Interstitial lamellae was present between two concentric lamellae. So it is mainly lamellar, consisting of Haversian canal. Central portion is the Haversian canal, and between two concentric lamellae we have our interstitial lamellae. Now the thickness of this alveolar cortex, cortical plate or alveolar cortex, it is also known as cortical plate or alveolar cortex, right? So its thickness is variable. It is thicker in some region such as mandible than that of maxilla. So cortical plate is thicker in mandible than maxilla. It is mainly thicker on lingual side as compared to buccal side. Lingual then buccal. So this cortical plate is also known as what? Alveolar cortex. It is mainly lamellar. It is similar to compact bone structure. It is having Haversian canal as well as interstitial lamellae, thicker in mandible. MCQ question. Cortical bone is thicker in mandible or maxilla? Mandible. More in lingual as compared to buccal aspect. Now coming to cancellous bone, as we had discussed, it is also known as trabecular bone or spongiosa or spongy bone, right? This is present mainly in between the two bony plates and between lamina cribriformis. It consists of delicate trabeculae between which marrow spaces filled mostly with fatty marrow. So it consists of what? Trabeculae in between the marrow spaces. Between marrow spaces. Filled mostly by fatty marrow. It is present in regions of maxillary tuberosity and angle of mandible. So it is mainly made up of trabeculae in between the marrow spaces. These marrow spaces are mainly filled with fatty marrow. They're more common in region of maxillary tuberosity and angle of mandible. So here there is presence of trabeculae enclosing marrow spaces, mainly found in interradicular and interdental spaces. Maxilla more common. Now this cancellous bone in arrangement of trabeculae is different. There are two types, type 1 and type 2. Type 1 and type 2. Type 1 interdental and interradicular. Interdental between two teeth, interradicular between roots of teeth. Trabecular are regular and horizontal in a ladder-like arrangement. So in type 1, what is there? Interdental and interradicular trabeculae are regular and horizontal. They are regular and horizontal. In a ladder-like arrangement. In a ladder-like arrangement. So you should be thorough with this. They're regular and horizontal in a ladder-like arrangement. So type 1, how is the arrangement of trabeculae? Ladder-like and horizontal. Ladder-like and horizontal. Type 2, irregular and arranged. There it shows irregularly arranged, delicate, interdental and interradicular trabeculae. Type 2 shows what? Irregular, arranged, delicate, interdental and interradicular trabeculae. So we completed with the alveolar bone. If alveolar bone is asked, then you should be thorough with this mainly. Its parts. What is alveolar bone? It is also known as alveolar process. Definition: that part of maxilla and mandible that form and support the tooth socket. It has two parts. We should describe both the parts: alveolar bone proper and supporting alveolar bone. Formed from what? Alveolar bone proper is also known as what? Cribriform plate. It is radiopaque. It is known as lamina dura, covering the thin white line covering the roots of the teeth. Lamina dura. Interdental septa, interradicular septa, we have discussed both. Zuckerkandel and Hirschfeld canals. Here, what is there? Interdental, interradicular arteries, veins, lymph vessels and nerves are present. Supporting alveolar bone consists of cortical plate and cancellous bone. Cancellous bone, trabecular bone or spongiosa, while cortical plate has structure similar to compact bone, as we had discussed in our starting of the chapter. Vascular supply of alveolar process, mainly anterior and posterior alveolar arteries, and for mandible, inferior alveolar arteries. So we have completed with our alveolar bone. Bone coupling, you can get a MCQ question on bone coupling. What is bone coupling? It is interdependency of osteoclast and osteoblast in bone remodeling. So what is coupling? Interdependency of osteoclast and osteoblast in remodeling. So coupling is mainly interdependency of osteoclast and osteoblast in remodeling. Mediators for bone resorption. There are stimulators, there are inhibitors. Stimulators may be interleukin, interleukin 1, interleukin 6, prostaglandin, parathyroid, rankle, and inhibitors may be OPG. Right. So coupling is very important. Recently, it was asked in one of the NEET exam also. What is coupling? It is mainly interdependency of osteoclast and osteoblast in bone remodeling. Coming to bone resorption. Resorption is caused by what? Which cells? Osteoclast cells. So there are stimulators as well as inhibitors. Stimulators may be rankle, because combination of rank and rankle causes resorption, right? So rankle, parathyroid hormone, interleukin 1, interleukin 6, PTH, parathyroid hormone, tumor necrosis factor, TNF, macrophage colony stimulating factor, MCSF, colony stimulating factor, prostaglandin, and inhibitors for resorptions will be OPG, osteoprotogerin. This OPG combining with rankle inhibits the resorption, right? As we had seen. Calcitonin, IFN gamma, that is interferon gamma. Androgen, estrogens, androgen, estrogen. So these are the stimulators as well as inhibitors for bone resorption. What is bone coupling? Interdependency of osteoclast and osteoblast is known as bone coupling. Once resorption starts, osteoclasts are important for resorption, but after resorption, formation of bone is also important, so osteoblast will also play a role. So this is bone coupling. For resorption, inhibitors as well as stimulators. Inhibitors, stimulators, rankle, parathyroid, prostaglandin, MCSF, colon stimulating factor, and inhibitors are OPG as it is secreted mainly by osteoblast. Calcitonin, androgen, estrogens. One more terminology, cutting cone, filling cone. Part of bone which shows resorption, beginning of resorption is known as cutting bone. Part of bone which shows initiation of resorption, that is cutting bone. And filling bone, laying of new bone. Part of bone that shows laying of new bone, that is filling bone, and part of bone that shows initiation of resorption, that is cutting bone. Now coming to age changes in alveolar bone. Osteoporosis, decreased vascularity, reduction in metabolic rate, right? Osteoporosis, decrease in vascularity, decrease in metabolic rate and healing capacity. Healing capacity, we all know it will decrease with age. Bone resorption may be increased, decreased vascularity, irregular periodontal surface, thinning of cortical plates, thinning of cortical plates, reduction in number of trabeculae, thickening of collagen fibers, reduction in number of trabeculae, thickening of collagen fibers, thickening of collagen fibers. Clinical considerations, we have seen osteoporosis, thick bone, difficulty in tooth extraction, osteoporosis, loss of bone, osteopetrosis may be present, thick bone, difficulty in extraction, right? This will be the clinical considerations. Now coming to fenestration and dehiscence. Isolated areas of the root, isolated areas in which the root is denuded of bone and root surface is covered completely by periosteum. So fenestration, what will happen? Isolated areas in root, it is denuded of bone and the root surface is covered by periosteum. Bone is not that, but covered by periosteum. Denuded by bone, but covered by periosteum. Dehiscence, denuded area extends through the marginal bone. Complete involvement. Dehiscence extends through the marginal bone. So we have not seen the diagram for the cribriform plate, right? We will see the diagram now. This is our spongy bone, trabecular arrangement in between the teeth as well as the roots, compact bone, cancellous bone, sieve-like arrangement. You can see in this diagram, easily appreciate compact bone and cancellous bone. So this is our Havesian canal, concentric lamellae. In between the concentric lamellae, we have interstitial lamellae, and surrounding that we have circumferential lamellae. Parts of alveolar bone. In this diagram, we can easily appreciate cortical plate, sieve-like arrangement of cortical plate. Alveolar bone. This is alveolar bone. This is cancellous bone. Here, radiographically, you can see a white line surrounding the root of the tooth. That will be our lamina dura. So we've completed with our alveolar bone. You should be thorough with mainly alveolar bone. What is the parts of alveolar bone, right? Which factors are involved in bone resorption? So stimulators and inhibitors for resorption. Also, we have discussed what is bone coupling. We have discussed cutting cone, filling cone. Part of bone where resorption starts is cutting. Where new bone is formed, it is filling. Supporting alveolar bone consists of two parts, cortical and cancellous bone. Cortical plate is same as compact, and cancellous, there is presence of trabeculae.